So today we're going to be talking about Lewis dot diagrams. Lewis dot diagrams are going to be pictures that show us how atoms come together to form a molecule and how they're sharing electrons within that molecule. Now, when we're talking about Lewis dot diagrams, we're going to be showing how the electrons are shared. But I don't care about all of the electrons. I only care about valence electrons. Valence electrons are the electrons in the outermost shell. These are the ones that can be lost or gained in ionic bonding. These are the ones that are shared in covalent bonding. These are the ones that react in chemistry, and they're the only ones that I care about. So when I'm looking at my periodic table, here's how I determine valence electrons. My valence electrons represent the group that the element is in. So I would add these numbers to my periodic table. It'll make your life easier as we start drawing Lewis dot diagrams. But everything in group 1 has one valence electron. So hydrogen, lithium, sodium, potassium, they all have one electron in their outer shell. Beryllium, magnesium, calcium, they all have 2. I skip everything in the middle, come over here, 3, 4, 5, all the way to 8, okay? Now remember, we're gonna be drawing Lewis dot diagrams for molecular compounds. Molecular compounds are 2 or more non-metals that share electrons. So I'm gonna be living over on this right side of the staircase with one exception. Hydrogen is also a non-metal, so he'll be in some of these compounds as well, okay? Otherwise, I'm gonna be living over here. So my first molecule is Br2. So this column is where I'm going to be doing my math. So I find Br on the periodic table. Br has 7 valence electrons. But because I have 2 Brs, and they each have 7 valence electrons, I'm going to have 14 electrons to work with. Now, when I draw the picture, I'm going to draw Br twice because it's Br2. And then I'm going to connect those 2 Brs with a single line. This single line is a covalent bond. It's a bond between 2 nonmetals where they're sharing electrons. Anytime I draw a single bond, it's worth 1, 2 electrons. So I started with a total of 14 electrons. I've used 2 of them. So I have 12 left to draw. Now these are called Lewis dot diagrams. The dots I'm going to be drawing, and I can draw 12 of them, represent electrons. And they're not going to just get thrown in haphazardly. The other day we talked about something called the octet rule. We said that all of chemistry occurs because everybody wants magic number 8, oct, prefix octa for 8, valence electrons. That'll give them a full outer shell. So I'm going to draw dots around the outside to get to magic number 8. Bromine has this one line touching him right now, so he's got 1, 2 electrons. If he wants to get to magic number 8, then I need to draw 1, 2, I draw them in pairs, 3, 4, 5, 6 more dots. 1, 2, 3, 4, 5, 6, and the line makes 7, 8. This bromine is exactly the same. He has 1, 2 already, so he needs 3, 4, 5, 6, 7, 8 to get to his total. Okay, I was able to draw 12 dots, 6 on this bromine, 6 on this bromine. Both made it to magic number 8, so everybody's good. Okay, phosphorus triiodide. Phosphorus has 5 valence electrons. This time, there's only one phosphorus. Iodine has 7 valence electrons. And I have 3 iodines. 7 times 3 is 21, plus 5 from phosphorus. I have 26 electrons to work with. Now, when I draw dots, I draw them in pairs around the sides of my atom. When I draw more than one element, I draw them on the same sides, top, bottom, left, and right around the central atom. The way I determine my central atom is, in this case, I've only got one phosphorus, so he's going to be in the middle. I've got 3 iodines, so they're going to be on the outside around that central atom. Just like I did above, I'm going to connect each of my atoms with a single line. Just like above, each single line is worth 2 electrons. So I've used 2, 4, 6 electrons in my picture already. I started with 26 electrons I was going to draw. I've drawn 6, so I need to draw 20 dots. Everybody's trying to get to magic number 8. So let's start with iodine first. Iodine has 1, 2 already. He wants to get to 8, so he needs 6 more. Same thing with this iodine. He's already got 2. He wants to get to 8, so he needs 6 more. Same thing with this iodine. 6 more. If I look at phosphorus, phosphorus also wants to get to 8, but he has 3 lines touching him. That means he's already sharing 6 electrons. 1, 2, 3, 4, 5, 6. So to get to magic number 8, he only needs 2 more. 2, 4, 6, 8. Okay. So I had 20 dots to draw. 6, 12, 18, and 2 on phosphorus is 20. Okay. CF4, carbon tetrafluoride. Carbon has 4 valence electrons, and there's only 1 of him. Fluorine has 7 valence electrons, and there are 4 of him. 7 times 4 is 28, plus 4 is 32. I have 32 electrons to work with. Because there is only 1 carbon atom, he is my central atom, and it's CF4, so I'm going to draw 4 Fs around the outside. Again, top, bottom, left, right. Just like before, I'm going to connect each letter with a single bond. Now, Because each line is worth 2, I've used up 2, 4, 6, 8. I had 32 electrons to start with. I now have 24. Okay? So let's start with fluorine. Okay? He's got one line touching him, so that's 1, 2 electrons. He wants to get to magic number 8, so he needs 6 more. That's going to be the same for every fluorine atom. Every fluorine atom has one single line touching him. The single line counts for 2 electrons, so they need 6 more dots to get to magic number 8. Let's look at carbon. Carbon has 4 lines touching him. 1, 2, 3, 4, 5, 6, 7, 8. He's not going to need any more dots. He's already hit magic number 8. So I want to check my math. I was told I could draw 24 dots. 6, 12, 18, 24. Everybody made it to magic number 8, so that's a good diagram. Okay, let's try one last one together. So H2S, hydrogen, despite being a non-metal, lives all the way over here on the right, or sorry, on the left. He has 1 valence electron. Because the formula is H2S, I multiply that by 2. Sulfur has 6 valence electrons. There's only 1. So I have 8 electrons to work with. Okay? Now, just like before, S is my central atom because there's only 1. There are 2 H's, so I put them on the outside and I connect them with single lines. I had 8 electrons to work with. I've used 4. I can only draw 4 dots. Hopefully by now you see the problem with this picture. I have 4 dots to draw, but if I'm getting everybody to magic number 8, that's not going to happen. Octet rule says everybody wants a full valence shell. Octet rule says that's magic number 8. Except if I'm looking at hydrogen. Okay, hydrogen lived up here. His electrons are in the 1s orbital. Hopefully we remember where electrons lived and the shapes and the sizes. My 1s orbital can only hold a total of 2 electrons. Once it has 2 electrons, it's full, and I move on to the next level. This would be the next valence shell. The next valence shell can hold 2 in its S, 6 in its P for 8. 2 in the S, 6P for 8. Hydrogen, nope, he doesn't have a p orbital, he just has an S, he's full with 2. So when I draw hydrogen, hydrogen gets 1 line, only 1 line. Then he's got his 2 electrons, he's full, he's done. Hydrogen can never have dots on him. Hydrogen can never be the central atom with lots of lines attached. Hydrogen gets 1 line and then he's done. So hydrogen here has 2, he's done. Hydrogen here has 2, he's done. Sulfur has 1, 2, 3, 4. To get to magic number 8, he needs 4 more dots. 1, 2, 3, 4, 5, 6, 7, 8. I was able to draw 4 dots. Those go on sulfur, and now he's got 8. The hydrogens are happy with 2.